This is lesson 1.3, line segments. A line segment is a measurable part of a line that consists of 2 points called endpoints and all of the points between them. The 2 endpoints are used to name the segment. As we learned in the previous lesson, lines have arrows and line segments do not have the arrows because they have endpoints that stop. You still name them the same way, either order of letters is fine, and you still use 2 letters to name a line segment. For example 1, we are looking for the length of SU, and in order to find the length of SU, we need to add the left segment, ST, plus the right side segment, TU, and that will equal SU. This is called segment addition postulate, which we'll learn more about later on. But we're just basically adding segments, and a lot of you probably saw, well, of course, we're just going to add them together, and that will give us the total. And so if we add them together, we get 13.2 centimeters for SU. What if they give us, on example 2, the total and one of the segments? How do we find the other segment? Many of you are probably thinking subtraction. Also in the directions there, kind of giving you a hint. And so on this example, we are seeing fractions. We will not see fractions on a test or a quiz, but since I'm here to guide you, we will do this one with our fractions. So when we go to try and subtract, we look at our fractions here, and they are both having a denominator of 8, which is good. We need them to be common denominators in order to subtract. But when I try and subtract 5 minus 7, we get a negative, and we don't want that when it comes to distance. So we need more in our numerator up here on the top. So what I'm going to do is I'm going to steal a whole, which out of 8 out of 8 is the same thing as 1 whole. So I'm going to go ahead and add that whole, but in the form of 8s, to this fraction here. And so now I'm going to go ahead and move over here. We have 11, and then instead of 5, we have 5 plus 8, which is 13. So we have 11 and 13/8 minus 3 and 7/8. And we can go ahead and now subtract 13 minus 7, which is 6, and then 11 minus 3, which is 8. And we can reduce that. 6 over 8 can reduce to 3/4. So if you recognize that, then go ahead and definitely do that, simplifying. This next example is actually super similar to the examples up above. We just don't have our picture. And so it's kind of hard to tell what all of this means up here in the directions when we really don't have a picture to guide us. So we need to draw a picture, and so we are going to draw a segment. And in order to find the value of x and xy, we need to draw this picture right here, which is y is between x and z. So somewhere in the middle, we're going to put a point and put a y. It doesn't necessarily have to be right in the middle, since it just uses the word between. And then x and z, it doesn't matter which end we put them at, but we need x and z there on our endpoints. And now we can go ahead and fill in our information. If we have xy is 19, then over here where xy is that segment, I'm going to go ahead and put a 19 above. Yz is right here, so 2x plus 5. And then xz kind of comes around here in the tail end of the 12 there. So 6x, this is our total, 6x plus 12. I'm going to go ahead and kind of put brackets with that to show that's the whole. And so just like up above, we now are going to be adding our segments, so left plus right, but this time we have the total, 6x plus 12. So we are going to be putting our 19 plus our 2x plus 5, the left plus the right, equal to the whole, which is 6x plus 12. And now we're going to combine like terms, the 19 and the 5. And then I like to get rid of this smaller variable, that way I don't deal with negatives, but get them together. And then we're going to solve this two-step equation, subtract 12 and divide by 4. Now, once we get x, a lot of times we think we're done, but we want to double check, oh, we got x, but it wants us to find xz as well. And so over here, if we look at xz, it's the entire length, which is the 6x plus 12. And so what do you think we're going to do with that 3? That's x. We're going to, plug it back in so we can find the length of xz. So 6 times 3 is 18, and 18 plus 12 is 30. Now we have our two pieces of information, and we are done. This next one of using betweenness of points, we have kind of another segment here. This one is bungee jumping. You will find me on the ground, maybe watching. All right, so we kind of have this 400 foot length here, but we have it kind of split up into sections. We have from the bridge down, that's going to be our bungee cord. And then we have Trevor here, and then we have the space from Trevor's head all the way to the bottom of the canyon. So for the bungee, we have 9 feet more than 10 times the distance. Well, we don't know the distance between Trevor and the canyon, so that's going to be a 10x, and then 9 more than is going to be a plus 9. So the bungee is really a 10x plus 9. We know Trevor is 6 feet tall, and then we don't know that distance between Trevor and the canyon, so we're going to put an x there for that last space from his head down to the canyon. But we do know the total is 400. So each of these 3 pieces here we're going to add together, and then we're going to set it equal to 400. And so we're going to combine like terms. 10x plus the 1x, we know there's 1 there, is 11x. 9 plus 6 is 15. And then we are going to solve that two-step equation. And he is 35 feet from the canyon, so he has got extra room there. All right, this last question here deals with the word congruent, and congruent means the same size and shape. When we talk about congruence, we talk about figures, so not actual measurements. Measurements or numbers are equal, but figures and shapes, especially in geometry, can be congruent or the exact same size and shape. We use this symbol right here, a little equal sign kind of with a squiggly or tilde up above, and that is meant to read congruent to. We can also use slashes or tick marks, as I like to call them, and those indicate the segments are congruent or the same size and shape. So in our last example, again, we need a picture where B is between AC, but this time we know that AB, the left, is congruent to BC. So that B not only has to be in between, but smack dab in the middle between, creating this left and this right side being congruent or exactly the same. So now we can go ahead and fill in our AB is 8x minus 6, and it looks like we have our AC, our total. Oh, we don't have BC though, or do we? If this AB is the same as BC, then this would also be 8x minus 6. So you can actually do 8x minus 6 plus another 8x minus 6, since we have this being equals 52, and solve it that way. There is an alternative way. You can also think of this as being half of 52, so you could take your 8x minus 6 and set it equal to half of 52 and solve that way if half is easily done. And so either answer, either way that you solve it, should get you the correct answer for x. So if we solve it this way, x is 4. And then up here, if we solved it with our combining the two left and right segment there. Then you can see we do get x is 4 either way. And all we needed to do was find the value of x, and we did. So we are done.